So I'm going to talk about telemetry today, kind of also known as kryptonite to a lot of us. It's kind of a scary thought, a scary idea. None of us really like it, except when it's helping us out, when it's helping us make some development decisions, right? It's how we know what we want to work on. So today I want to talk about a take on metrics that's focused on helping you just as much as it is on helping us. So get started. If you have been around on the Slack, GitHub, etc. for a while, you may have run across me. I'm Ben. Been for 2K on a lot of the places. You've probably seen me grouch about not knowing how people use Puppet, holding us back. So that's kind of what I'm going to be talking about today, is like what I'm doing to try and understand how people are using our tools so that we can more easily make decisions and more easily improve the things that people are using, and also to expose that to people in the community who are also making those decisions and deciding what parts of their modules they need to focus on. And really, that's what metrics is all about. It's like knowing how your tools are being used, and not knowing those tools is like flying blind off into like this white cloud of nothingness. So right now today, it's really pretty easy to get started building a simple module for a single purpose to accomplish a task, to build it for your environment. You get started, you just identify what you want to solve and PDK new module, and it almost automates the entire process of building a module. And then you just have to punch in some code. VS Code and the Puppet plugin makes that pretty easy. And we've even got automated tests built in, PDK validate, PDK test unit. So where's the problem there? The problem comes is when you want to maintain it, when you want to improve it, as when you want to grow its user base, because then you start getting into scope creep. Somebody like Tim's going to come in and say, hey, can we add some Arch Linux support to this? Sure, but I don't use Arch Linux. I don't know much about it, so I'm not really the best at maintaining it. What about Windows 2012? What about a PR to add something? Each one of these things is added functionality that's more complexity to maintain, and each of those has a cost, right? So every platform, every feature you support takes maintenance time, and often it takes dollars, So in order to make the most effective use of our time, we really need to focus on the code that is most used. If people aren't actually using something, then dedicating maintenance time to that is just wasted, especially if that code adds some kind of complications. If it makes your testing more fragile, or if it makes the user experience more complex, or if the code is harder to read because you have unnecessary abstractions. Like I have an old Drupal module that I wrote some time ago that actually dynamically includes subclasses based on this weird complex case statement and a lot of string interpolation. And why really? It was scope creep. It was things that people didn't use, and it was unnecessary abstractions that really just kind of made that module a nightmare to maintain. I remember some time ago reading an article that explained that businesses should sort of, air quotes here, fire customers that cost you more to keep than they actually generated in revenue. And likewise, sometimes we need to fire code that just isn't worth maintaining. But then how do we know that? How do we make those sort of decisions? Well, with all due respect to Robert Frost here, as developers, we actually want to take the road that's most traveled. And just like seeing the wear patterns in these two roads, knowing the usage patterns of our code is how we know what people are using, how we know what to focus on, or what code to get rid of. Some of us have had the pleasure of working on software as a service applications. And so we're used to that kind of easy access to profiling metrics, because those kind of platforms have the endpoint tracing just built right in, and you just sort of get it for free. Like, for example, Twitter always knows what parts of their platform are used most consistently. But when we have on-prem software like Puppet modules, we have to figure out how to get those usage patterns in other ways. So I'm going to start out with this framework. I'm going to start out with impact analysis. And that basically means identifying the effects of changes that we're going to make. And it's mostly effective when you can do that before breaking things. Like it's really easy to see the impact after you break something. You just listen to see who's screaming. But that's not very effective. That's not helpful to your community. If we can identify that before we break those, then we can actually move a lot faster without hurting people. The rangefinder is a tool that I've been working on for a little while. You may have seen a couple of releases or some talk about it. It basically just identifies what public forge modules might break if you change your code. So you run it on a file. It'll figure out what that file creates and tell you what forge modules use that thing. So in this example, I ran it on the concat module. I ran it on the fragment.pp manifest, and it identified that that's a type and that there are a whole bunch of modules on the forge that are using it. And if I change how that fragment works, if I change its interface, or if I break it even, all of these are the modules that are going to be impacted. You can also run it against a whole module, and it'll just kind of iterate through everything that module creates. It's now also available as a GitHub application. I'll share out a link to the page later on. I haven't listed it on the marketplace yet because I'm trying to do a sort of a slow rollout. But this will look at every PR that comes into your project, and it'll run effectively that same process on that PR. So it'll identify what files were changed in the PR, and then it'll run the tool against those files and figure out this PR might impact these modules. So in this example, if this PR had actually broken the function that is listed, then these 9 modules on the Puppet Forge are the ones that are using it. So not only do you know how big that impact might be, but if you're intentionally making changes, you could even reach out to these people and say, hey, here's a PR to fix this thing that I changed, to change the interface or something. The way that it works is basically static analysis of the source code. It downloads modules from the Forge, and it just sort of dissects them into all of its little parts and identifies what those module that module uses. So it'll identify what resource types that might be declared. It identifies what functions will run, what classes it uses, etc. And it's not something that works on runtime. It just looks at the code itself. So it's all possible things that this code might declare. And the tool runs on a cron job every week. So it goes and it generates this dependency network every week and shares that into a BigQuery database. Now, this is public, and this query that you see here, you can go run it yourself. All you need is a Google Cloud account, and you can go get this kind of data yourself. I've got information on that and on the data set in my blog, benford2k.com. And I'm also going to share out a couple of links right after my talk. But if you were paying attention, there's a big limitation. It only works on public Forge modules. So it doesn't know if your code is used by profile modules or modules that haven't been released, or if they're used internally in like a site manifest or anything. All it knows is whether or not your code is being used by other Forge modules, which is a great first step. But to truly know the spread and the impact of breaking changes in my module, I really need to know the production usage patterns from infrastructures actually using modules and actually using the parts of modules. But then that's immediately a gigantic privacy red flag, right? So anytime a tool that I use phones home, I immediately wonder what it's gathering. Like whether it's sneaking information that I don't really want to share. Like many of you, I run Little Snitch, and Often I'll even bust out Wireshark and just see what things are being reported home. So privacy and maintaining your trust was the first thing on my mind when I started building this framework, when I started designing this framework. The obvious first step here is business identifiable information. Most of you probably are aware of PII, personally identifiable information, especially with GDPR and other things that have been coming down the pipe lately. But a lot of those same kind of things apply to businesses as well. Because if you share too much information about how your infrastructure works, you're just asking for somebody to use that information to compromise, to do like reconnaissance against you and figure out what software you're running and how it's vulnerable or how your network is laid out, et cetera, et cetera. And because of that, a lot of companies don't even allow phone home metrics at all. But even more insidious there is fingerprinting. And that is identifying individuals by properties or habits. And that also applies to infrastructure. And here's an example that I just threw up there. If you saw like a telemetry report and you saw that this infrastructure reported back that it was in the Central European summertime zone, and it had the locale set to Swiss French, and it had hundreds of thousands of nodes that were all classified with various high-performance computing modules, you might take a guess and guess that you might be looking at CERN. And then you could use the rest of that record to gather insights about how their network was laid out. And nobody wants that. So this will probably, let me see if I can do this. So panopter, I don't know if how many of you have used this before. It's basically just a service offered by the EFF that'll actually look at your browser, even if you've got all of like cookies turned off, all of the privacy protections, et cetera, et cetera. It really is frightening how much information that they can gather about you. Now, my test here is done, and it says your browser has a unique fingerprint. And there's almost 300,000 nodes that have been tested over the last month or so. And out of those, my browser is absolutely unique. And these are the things that it's looking at, just like the user agent, HTTP headers, what plugins are installed, time zones, screen size, fonts, etc. None of those things seem to be very private. None of those things seem to be concerning at all. But if you combine all those together, you can find a lot of information out. And that's pretty frightening. So the hard requirements, the invariant criteria that I set as I was designing this framework are that it has to provide real value to you. Something that I'm asking you to do in exchange for something else. It's not something that I'm begging you to do. It's if you share this data, you're going to get benefit from it. And we have to be transparent about what's being collected and why, and how we're using it. And it's opt-in, so we can't gate anything on it. And everything, I made a commitment right from the beginning that everything that we collect is going to be aggregated and shared publicly so that you can use it yourself. So let's look at how that process works a little bit, and I'll show you how that we're meeting those requirements. I'll talk about the model first, and then we'll talk about some of the tech behind it. So the public data set that you have access to, you don't get access to individual records at all, ever. We don't either. This is an example of getting the top 10 most used classes in the ecosystem right now. And it's pretty straightforward. You just select the name and the count from the class usage count table in the aggregated data set. All you need is a Google Cloud account, and you can get to that. And note, you don't see the records themselves. You cannot see the complete set of classes that any one site is using. All you can see is like pre-computed sums or counts or other kind of aggregations. Now, you notice that the results here are kind of silly, and that's just because the data is super limited right now. only the alpha beta testers have reported in. So there's only like 20 or so. So this data is generated by a whole bunch of little SQL queries. They're pretty straightforward. It turns like individual records into aggregated tables that just like pre-compute those metrics that we talk about. So all of the nodes out in public kind of check in and they send their information to our private internal database, and then these queries run, generates a statistical data, removes anything that could be used to identify any record or any site, and puts it into that public data set. So each one of these queries generates a table, and right now we don't really have a whole lot, but we're going to be adding them as we learn different, interesting, useful ways to dissect the data that we've been collecting. And in case you've been admiring the imagery in my deck so far, up until now, this omnigraphal thing here, this is how sophisticated my actual own images are. So I'll just put that out there. But now that private data, what about that? Again, the information that we collect isn't terribly sensitive all on its own. We're just getting like what classes are being used, what functions are being used, what public Forge modules do you have installed, those kind of things, just so that we can help developers make decisions about what they support. But because of the bits that they collect, they are fingerprintable. So they're only stored in that secure data set, and very few people have access to it. Right now, it's only myself and our BigQuery admin team, and they don't really have any interest whatsoever in what's in the database, just that it's running well. And then the key point here on this slide is that our own developers who want to use those metrics, they have to do it via the aggregation queries, just like anybody else would. So now I want to talk about how the telemetry framework itself protects your privacy and how it keeps itself internally consistent by the way that it's designed. So the metrics are all designed as self-contained plugins, and every time they run, they're validated for consistency to ensure that they only collect what they've claimed. The plugins are designed as hooks. You have to describe what the metric collects. You have to provide a schema that is the data that your module will collect, or sorry, your plugin will collect. So many uses of the word module, right? Example gives a representative example of what data could look like, and I'll come back to that and explain what that is actually used for, and then just run. Gather the data and returns real data. So you don't have any other things that you can do. You can't report back other information. You can't. You're not responsible for the actual sending of the data. All you do is collect it, return a data object, and then the framework actually handles turning it into a report and sending it back. There are a couple of optional hooks that let you do a little cleanup, separate your code out into cleaner stages, but those are only if you want to use them. So that schema hook, it describes the data your plugin is allowed to work, allowed to return. And it returns a part of a BigQuery schema, which is basically just an array of rows. And you'll see that that is a single item array here with a hash that describes what that row looks like. Now, you can return more metrics if you want, and you can return more complex items. There's examples in the code base right now. This is basically just kind of the bare bones minimum. This is a single item, a single number. And then if you run the tool, dropsonde dev schema, it will collect all these together and return the actual full complete schema of everything that the tool can generate, all the plugins together. And then run just generates the data and returns it back to the framework. And it also just returns an array of rows of data. It runs on the Puppet server, so it can get any information that the Puppet server has access to, and you can use the code base. You can use Puppet itself, the Puppet libraries, to like iterate through environments or anything, and you can use PuppetDB, make queries against PuppetDB. And then the key thing here is that if it doesn't match the schema, the plugin will just completely fail, and it will no information will be returned. So now the example hook, that's the one that kind of is a little bit weird at first, but if you think about it, if we have data that you don't get to look at, and that data is going to be aggregated into actually useful data that you do get to look at, you don't get, it's not very easy to write queries and develop queries if you don't have something that looks like the same kind of private data. And so what this does is every plugin will return a single item, return an item that's representative of what it will or what it could return. And then all of that is combined together to generate a data set that resembles the private data set. And it also must match the schema, just like the other one, just like the run hook, or the plugin will fail. And this is how we generate those aggregation queries, is we develop them against this example database, and then we run them on the live production database. Now, from the command line, you can preview a report, and you can see exactly what will be returned. All you need to do is just run it with preview. And this command line flag that I use simplified it to just a single metric instead of returning all of them. But you see that there's a list of all the metrics, a description of what that metric is gathering, and then the actual number. You can also return it in JSON format if you are interested in using this tool for other purposes. Like, for example, if you wanted to use it to gather all of the modules that you used in your infrastructure, you could easily do that by just exporting JSON here and then consuming that in whatever tooling that you wanted. Now, the site ID is a cryptographic hash. And all it does is correlate the reports so that we can keep them, as it checks in each week, we don't want to assume that they're different nodes. We just, consider that to be one site. It's not reversible. Like, I have no idea who this node is, just that it is a single node. But if you do want to change that, if you want to show up as a different anonymous site, you can provide a seed value, and it'll generate a new hash for you. And again, the big thing about that is that the plugin cannot return data that it doesn't declare. So if you look at the schema, you'll see exactly what will be collected. If you look at the preview, you'll see exactly what will be returned. And the module itself, or the plugin itself, is not physically capable of returning anything that's not declared in those. And even if it did, the database schema that we use on the back end, it's generated from that same plugin schema. So that's literally how we generate the schema for the data set, is we run dropzombi dev schema and use that to build the data set. So now, how do you use this? Pretty straightforward. All you need is a Google Cloud account, and then you can go click through and explore that data set. Here is a representation of what one of the tables in that data set looks like. It's just a list of the environments and how many environments a particular node has. You see in this example here, we have one extreme outlier that has 236 environments, but most nodes are somewhere on the order of just a handful. We also have a lot of other information in that data set. So we've got that Forge module metadata that I showed earlier. We've got static analysis of the Forge modules, which is what enables that rangefinder tool to run. We're also pulling in and mirroring all GitHub repositories, public GitHub repositories that look like Puppet modules, and then this aggregated telemetry data. So you can combine those however you want. Like this is an example query that will show you a list of all the modules on the Forge that define custom native types and also happen to be hosted on GitHub. So what else is possible? We don't really know. We have a few ideas. I want to incorporate that impact analysis into the PDK validation. So when you run the PDK testing, it'll tell you how many things might be impacted by your changes. I'm working with the Forge team to help surface a lot of these metrics, like directly on the Forge page, so that as you go to look at a module, you actually see how many people are using it in production for real, instead of just how many people have downloaded it. Like, we don't really care how many people run standard lib in their CI testing. What we care about is how many people actually rely on it and trust it and use it in their environment. And that's one of the major reasons for installing this module yourself is that it will get, by using it along with everybody else, it will get you better, more accurate Forge numbers. Fox Pupilai has a really neat tasks management interface that helps them manage all of their modules and keep track of what things that they need to do, like which modules are out of date, don't support the latest operating system. That's what I'm looking at right here. And they could easily incorporate some of this usage data into that interface. Or maybe you'll write something. There's a lot of things that I haven't even thought of. But like any good community project, it actually depends on you all to help out, either by using the tool, installing it, or by helping contribute, helping develop some of the metrics, develop some of the aggregation queries. So that's what I'm asking from you today. This is totally, completely opt-in right now. There's no plans currently for shipping it with the product. Hopefully, we will at some point, but right now it's going to be opt-in. So if you want to send me metric data, you'll need to install the module and classify your Puppet server. There are links that I'm going to drop into chat so that you can look at the data set itself, or so you can look at some of the queries and see how the data is generated. I also have a tutorial up on my blog on how to develop a metric so that you can gather information that that is useful for you as well. And it doesn't have to be strictly Puppet. It just has to be part of this ecosystem. Like, for example, Reed already made a plugin that helps him to see the impact of building a better control repository layout and a different type of Puppet file that'll let you more easily manage R10K deploys. That was a little teaser. He's working on that, and I hope that he'll do a presentation about it in the next couple of months, but I'll leave that for him to reveal. Or David could look at the Puppet webhook project and see how many people are using the different kind of chat op integrations. Or you could just build some tooling that uses it. Maybe you want to build like a VS Code integration that'll give you a warning if you're working on a file that is going to impact a lot of people if you break it. I would really, really like to see that one, as a matter of fact, to see like just-in-time help that or warnings of things that might come up, just like you do with other kind of syntax help. But really, if all you do is just install the module and classify your server, it would really, really help out a lot. And that's it for my talk. So I'll move into Q&A. Here are a couple of links that are pretty easy to find, and I'll also drop those into chat. And I'll open it up to see if anybody has questions.
Looks like there's a question in the chat. Let's find it.
Any plans on including this into the Tupperware images? I don't have firm plans there. It is a thought that I have considered. I kind of want to see what the community uptake is going to be and make sure that things like any hitches are worked out first. But yeah, it would be great to include it in Tupperware images. So if you have feedback or suggestions on that, do let me know because I don't want to step on toes.